Hey friends, it's Ian Khan, the Futurist here at the Humanoid Summit. I've got Pras with me. He's presenting tomorrow, and we're talking about evolution of humanoid robots here at the conference. A lot is going on, from software to hardware to form factor, the works. Pras, welcome to the Futurist here at the Humanoid Summit. Tell us a little bit about your company and what do you guys do?
Yeah, so I'm with Agility Robotics. We've been in the humanoid space for quite some time. We're coming up on 10 years, actually. So a little bit before a lot of the interest and excitement that you see here was kind of around. But we build Digit, a humanoid that's made for work. And we're deployed into manufacturing, logistics, warehouse and factory type applications, basically doing real work. We pick up totes and bins and move them around and load and unload machinery, and we're paid to do it. We operate with a robot as a service model.
Amazing. And you've been 10 years in the industry doing this. What has been the evolution from like the early days till now? How have things changed? What has changed?
Yeah, I think that what we're seeing is a confluence of a lot of technologies that have been building for a while that are finally all meeting to enable the technology to create humanoid robots as we see them today in the world. So over the past years, we've been building out technology for actuation. We've been learning about the physics of locomotion. And that's a lot of what the core technology we developed at Agility was, that spun out of Oregon State University. As we've developed in the last few years, we've also seen kind of energy storage and compute hit higher levels of efficiency, which was really necessary to be able to create enough computing power and enough energy storage to have a fully self-contained humanoid that can operate for long enough and affect the world with strong enough forces to be able to do useful work. And in the last 2 to 3 years, I'd say, what we've seen is this revolution in physical AI coming on kind of the tailwinds of the AI revolution that led to things like ChatGPT and DALL-E and all of these different transformer and diffusion models. Basically, those same techniques, it turns out, can be adapted into the physical world. And that's created this physical AI revolution that is now enabling us to rapidly bring capabilities to all of these hardware technologies that we've been putting together for the past few years. And that's really just accelerated the pace of development. And it's also brought together a lot of different components and suppliers and sub-industries to support the humanoid industry.
Of course, incredible, thank you. A lot is dependent on chips, as an example and I don't know which chips do you use in your robots generally, but looking at the chip industry, Nvidia is doing amazing, great stuff, the chip or others too. Chip industry has really transformed. It's kind of exponentially growing and doing things in the last 10 years. So how much of an impact is that making on what now robots can do that they were not able to do 5 years ago? Do you see that really changing in the next 5 as well? What do you see?
Yeah, we've certainly been enabled by the industries in the automotive and mobile space basically developing out a lot of processors that are more power efficient and dense than they ever were before. And with the recent trends in AI, basically the work that Nvidia had been doing towards allowing self-driving to make use of very compact and efficient accelerated compute has sort of transferred over into compute that fits really well into humanoids and other robots, and being compact and being able to host relatively large AI models. And so that's been a huge enabler for us. Going forward, I think what we're seeing is as the industry develops and people understand the use case a bit more, we're seeing compute that's more specialized to the needs of robotics, where it's able to directly take in the types of sensors that robots use in particular and output to the types of actuation and controls that robots are typically using. And that's making it faster and lighter weight to power these robots.
Incredible. What's your outlook on the next few years for you guys at Agility? What are you working on that you can tell us about that's coming up?
We're releasing a new version of our robot that's fairly exciting, that incorporates onboard safety to allow us to operate in cooperative environments. with humans. So that means that humans and robots can move around in the same environment without needing a barrier or a wall between them. Now, that is what's currently required in industrial environments to be truly safe at scale. You'll see robots that are moving around among humans, even here, smaller robots doing it. That's not really how you can deploy these robots safely at scale. Any robot which can pick up a 50-pound tote can also exert quite a lot of force on a human if it's misapplied. So that's what we've been focused on, is our new robot with all of this onboard safety and capability, and we're really focused on deploying with customers. We have a number of existing customers, such as GXO, Schaeffler. We just signed Mercado Libre, and we're getting the robots out into real work environments where they're doing real tasks that need to be done. We're going to continue that and bring our new platform to that space with even more use cases and even more expansion into these industries. For the next few years for us is really proving that humanoid robots are not just a lab experiment, that they can live and work in these facilities for real value.
Yeah, totally. Well, thank you so much, Pras, for spending time with us. It's really nice knowing what you're doing. You have a presentation tomorrow, I think, so best of luck with that. Give us your advice, final piece from you, to anybody who's trying to get into the robotics industry, whether it's humanoids or not, whether it's, they're starting their own company or they want to join a company, they just want to get into the space. What's your recommendation to them on what should they do?
I would say now is a great time to get into the space, but make sure that you focus on some specific part of someone's problem. Go out there and figure out, how could this technology be applied to something? And then there's a lot of technology to be applied. It's never been easier to get started. There's never been more open source technologies and reference implementations and component technologies that you can build upon. But all of that is contingent on you having something useful to do with it.
Yeah.
And if you don't do that, it can be a very big distraction.
Yeah, incredible. Well, thank you so much, Pras. Appreciate your time here and best of luck.
Thank you.
Thank you.